Welcome back to the second video in the lesson on parametric equations, lesson 7.5. Example 2 says to write the following in rectangular form. So we've done that with a trig equation with theta was our parameter. Now let's use one with t. So if I take the first equation, and you can start with either one. You can start with the x or the y. I usually start with the x. And I'm going to say, I'm going to solve for t equals so that I can plug it in to the y. I'm trying to eliminate the parameter and write it in rectangular form. So I would have x plus the 5 equals t squared. Add the 5 over. Well, now I just need t, so I'm going to take the square root of both sides, and I have x plus 5 is t. Well, that's close. Now I'm going to take that and I'm going to substitute that in for the y equation where I have 4 times the t. So y equals 4 times my t value of the square root of x plus 5. I have now eliminated the parameter. I now have a rectangular equation, no more t's, and it is just rectangular form with x and y. Let's try another one. If I would like you to write the following in a rectangular form of x equals the square root of t plus 4 and the parametric equation of y equals 1 over t, you will have to state some restrictions because you have a square root, and very often that will restrict your graph. So let's go ahead and try to eliminate the parameter. Again, we just want rectangular form. So when I do that, I'm going to try to just get t equals. So I have a square root. I need to get rid of the square root. I'm going to square both sides. So I would have x squared is t plus 4. And I'm close. I just need to subtract the 4, move it to the other side. So I have x squared minus 4 equals t. Now I'm going to take that and I'm going to plug it into the y, substitute it there, and so now I have y equals 1 over t, which is x squared minus 4. Well, you should recognize that. A rational equation, you should look at that and you go, oh, I know where the asymptotes are, and you know what some of the values are right away. Let's get a visual and get an idea of what that graph is doing. Let's see here. 1, 2, 3, 4. 1, 2, 3, 4. There we go. You know that you have asymptotes at 2 and negative 2 because your denominator cannot be 0. And if you remember from the graph, you've got these different quadrant here. And you can plot points and verify that the graph is of this nature. And let's go come in and do this. So that would be the graph of the rectangular equation. However, we have restrictions because this is really this parametric equation. So let's label and identify some of these restrictions. If I look at the x part of the parametric equation, if I notice that that is the square root of a value, well then I know that that has to be positive. I know that x is going to be a positive value. It could be equal to 0. I can take the square root of 0. Well, that right alone, right there, restricts my graph. I now know that x is going to be greater than 0, so I'm only playing on the right-hand side, right? Now, look at, so that came from that part of the equation. Now look at your rectangular equation. You know that your denominator cannot be 0. You know that x cannot be 2 if you're over here on this side. That has restricted your graph now, and your graph only exists right there. Okay? If our time is going to remain in those restrictions, all right, I have to remain over here. That is my graph then. It's restricted with these two restrictions. X is positive and it cannot be 2. Let's look at another example. Another example, example 4, is we're going to go the other direction now. I want you to use the parameter that I give you, and I want you to determine the two parametric equations for a specific rectangular equation. So I'm telling you that x equals 6 minus y squared. And I have to give you what t equals. We'll do another one here in a minute. But t equals x plus 1. So now we're going to go the other way, and we want to solve for x so that we can plug it in here and get our two parametric equations. When we do that, we're going to move the 1 to the other side. So we have t minus 1 equals x. That's my first equation. And then I'm going to substitute that right here into this equation. So where I have x, I'm going to put t minus 1 equals 6 minus y squared. So I have my first parametric of x equals t minus 1. I now need the second one. I need y equals. So I need to combine terms here. I'm going to move the 6 to the other side. That will give me t minus 7 is a negative y squared. Well, I'm going to take the square root, but before I do, I want to move that negative to the other side. So when I do that, I have a positive y squared, and I divide both sides by negative 1 essentially, and it will flip these. It will become 7 minus t. Now I can take the square root, and it will be, the y will be positive, right? If I take the square root of both sides, now I have y equals the square root of 7 minus t. That becomes my second equation over here. So there are the two parametric equations for that parameter. Okay? Let's get a visual, get an idea of what that looks like. It's easier if you just, let's see, t, x, y. Let's just get a few points here. When you have a square root, sometimes it's easier to pick points that you know are going to give you easy square roots, especially if you're doing this on your own. So I know that if I make t a negative 9, then I'm going to have 7 minus a negative 9, which will give me 16, which would give me 4. I do these first because this is the harder one. If I plug in a 3, 7 minus 3 is 4, square root is 2. If I plug in 7, 7 minus 7 is 0, so I know I'm at 0. Then I can go back and I'll plug in these t values here at x. So negative 9 minus 1 is a negative 10, 3 minus 1 is 2, and 7 minus 1 is 6. And then when I plot that, let's see here. I need to get to, remember here you're only graphing the x and the y. I need to have a negative 10 and a 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Glad your teacher can count. All right, so at negative 10, I'm up at 4. 1, 2, 3, 4, 2, 2, and 6, 0. We're doing this number here. Okay, but pay attention. That's the way the graph drew, and I'm going to erase that arrow right there because when I plotted my points, as I was coming in from negative 9, this was my first point, and the orientation is going this way. Here, t is negative 9. At this point, t was 3, and at this point, t is 7. That states the speed and the orientation by giving the graphs. Okay, let's do another example. So I'd like you to also use this parameter. We're going to use the same rectangular equation. So same process, we need to eliminate the x. We need to get x equals and use the t. So I'm going to move the 4 over, subtract the 4 from both sides, equals negative 2x. Now I'm going to divide by negative 2. When I do that, it will reverse these, right? It will be 4 minus t over 2. I'm going to put that negative up top. So now I've got my x equation. I guess I could just leave that there. Then I'm going to take that, remember, and I'm going to plug it into this rectangular equation that it gave me. So I have, instead of x equals 6 minus y squared, I now have 4 minus t over 2 equals 6 minus y squared. Now remember my goal, and this is just algebra, okay? I'm going to scoot this up. Now I need y equals. So I'm going to move the 6 to the other side. I'm also going to split this up at this point. And I'm going to put 4 over 2 and t over 2. So I'm going to make that 2 minus t over 2 minus 6 is negative y squared. So that I can put the 2 and the negative 6 together. So I now have negative 4 minus t over 2 is a negative y squared. Well, I have to do the same thing as I did earlier. I've got to get rid of that negative. So I'm going to bring that negative to the other side, divide everything by negative 1. Well, that just makes everything positive. So now I've got, because everything was negative, 4 plus t over 2 equals y squared. Again, I want y, so I'm going to take the square root of both sides. And let's go ahead and list our equations. X equals the 4 minus t over 2, and y equals the square root of 4 plus t divided by 2. So those are my two parametric equations. And now to get an idea, graphing those, I'm going to go ahead and I'm going to make another little t-chart. So I've got t, x, y. And again, I have a square root, so I'm going to plug in numbers that make this nice and make it easy to divide. That would be a negative 8 and a 0 and a 24. Let me show you why. If I plug in negative 8 divided by 2 is going to be negative 4. Plus 4 is 0, so I know y is 0. Here, if I plug in 0 over 2, that's 0. 4, square root of 4 is 2. If I plug in 24, 24 divided by 2 is 12. 12 plus 4 is 16. The square root is 4. And now it's easier to take these and you can plug them in here. 4 minus a negative 8 would give you a positive 12. Divided by 2 is 6. And such. You can plug these in. Now to get an idea graphically what that looks like, let me go ahead and sketch that for you. If you'll notice, the graph is the same, but our times are different. Another thing that's different is the orientation is different, because as t here is at negative 8, I'm starting here at the 6, 0 point, and I'm moving this direction orientation, whereas here we moved from left to right. Here we're going from right to left. I'm going to put some notes up here that I would like you to copy that regard how to put this on the calculator. When you do that, when you come to class, we'll be able to play with some of these, and I'll be able to better show you how this works. These are some notes that I would like you to copy, and we will go over them in class, but this is pertaining to how to draw the parametric equations on the calculator, and it's really fun. You can do a lot of cool stuff with them that we haven't been able to do so far. So go ahead and just copy this down, freeze it, and then we will deal with it in class. Also, I'm going to put up some kind of fun notes. These are notes that will help you draw ellipses, circles, and hyperbolas, and I also wanted you to have access to this. Again, we'll deal more with this in class. See you then.